Here's another problem from homework number 14. It says, assume that the Richter scale magnitudes of earthquakes are normally distributed with a mean of 1.172 and a standard deviation of 0.596. All right, so before we even attempt to get to the questions, let's go ahead and label up our graph. Here's the template, and X in this case is now the earthquake magnitude. Earthquake magnitude. Wonder if anybody's been in an earthquake. I never have, fortunately. All right, and in this case, we are told that on the Richter scale, which is a way of measuring earthquake levels, we are told that the mean earthquake magnitude is 1.172 with a standard deviation of 0.596. So I'm going to go ahead and mark my mean score right here on the graph, 1.172. All right. Now that everything's labeled, let's go ahead and ask our first question here. Earthquakes with magnitudes of less than 2.000 are considered micro-earthquakes that are not felt. What percentage of earthquakes fall into this category? So there's little earthquakes, I guess, all the time. It's just sometimes we just don't feel them if they're below a 2.0. So we have to figure out what percent. So when that's the question, we are looking for the area under the curve. And as soon as we have to find the area under the curve, we know we have to find a z-score. So let's mark 2.0. We can see 2 is above 1.1. I'm not exactly sure where, but with a dotted line, I'm just going to go ahead and approximate here. And we know that in this problem, x is equal to 2.000. And we are asked to find what percentage fall into this category. So anything below a 2 is not going to be felt. So we are looking for the area below the curve. Below. What percentage is this? Right here. All of this. All right. So before we can look up percentages, we have to find the corresponding z-score. All right. So we're going to have to use our formula. Z equals x, which in this case is 2.000, minus the mean, which is 1.172, divided by our standard deviation of 0.596. And that gives us 1.3. And I have 8926 and going on for a while, but because z tables only go out to the hundredths place, we're going to round to the hundredths place. So 1.39 is our z-score, 1.39. All right. So because z is positive and to the right of our mean, we need to look at our positive z-score table. So let's pull that up. All right, here's my z-table, my positive z-table, and looking up 1.39. Looks like here is 1.3, and here's 0.09 out to the hundredths place. So following this all the way over, 0.9177. 0.9177. Okay, so let's go back to our other homework page. Here it is, and then so this area under the curve is going to be 0.9177. Okay, go back to my yellow pen here. So just be careful because this is a percentage, and the question said what percent are below 2.00. It's going to equal 91.77%. Okay, so you have to put it in the form of a percentage, not in a decimal, if you're getting that wrong. All right, so let's now take a look at how we can do this with StatCrunch. I just wanted to take a minute and show you that. So go ahead and get out your StatCrunch tips, and I'm just going to open up a StatCrunch screen here. And if you followed your StatCrunch tips for chapter 6, you can see that you can click on Stat, and calculators, and we have a special normal distribution calculator right here. All right, make sure you can see that. And this is how it comes up, and we don't even need to do z-score calculations and standardizations because we can plug in the actual mean of the data that we're using. So the mean earthquake score was 1.172. It had a standard deviation of 0.596, 0.596. And in this case, we wanted the area less than. You can also do greater than, which is nice because, again, z-table only goes to the left. We were trying to find the probability that the magnitude of an earthquake was below 2.000. You can just write 2 and hit compute. And there you can see it comes out 0.9176. 0.9176. So if on your homework you are off by a percentage here and there or a thousandth of a point, try using StatCrunch because sometimes the z-table is ever so slightly off because we have to round sometimes. Okay, so let's close that, and that's the answer to part A. Let's take a look at part B. Letter B says earthquakes above a 4.0 will cause indoor items to shake. So those are the earthquakes we really feel. What percentage of earthquakes fall into this category? So again, we are asked what percent? So our answer is going to be in the form of a percent, and it's going to be, we have to find that number from the area under the curve. All right, so first of all, where is a 4.0? Well, our mean was 1.172, so I'm thinking 4.0 is pretty far out here. We're going to make it about here. This is where x equals 4.0. All right, so you could go straight to StatCrunch if you wanted to, but we're going to go through the exercise of finding it. So the first thing we're going to do is find our z-score. Z is going to equal x, which is 4.0, minus the mean, which is 1.172, divided by the standard deviation of 0.596. That will give us a z-score of 4.74. So 4.74. All right. So we're way out there. 4.74. This is, remember, z-scores are the number of standard deviations you are above the mean, so, or above or below. So this is, when you have a earthquake with a score of 4.0 on the Richter scale, that's 4.74 standard deviations above the mean. And if you jump back here to your z-table, you're going to see that we don't even go much past 3.5. If you look way down here at the bottom of the paper, you can see 3.5 is as far as it goes, because once you get out there, you are at 0.9998%. You know, you're almost 100% is below that. So it's virtually 100% of your population is to the left. And so therefore, it's not exact, but it rounds to the point of 0.0000. So that's as far as it's good. So 0% is going to be your answer for that problem. Okay, let's quickly take a look at that on StatCrunch, just so we can try it. In this case, our mean and our standard deviation is the same. This time we want to find the probability that our Richter scale score is above, greater than, or equal to 4.0. Very high Richter scale score. And if I compute that, you can see 0, 0, 0. It's so small, it's minute. We don't even get any cover. We're here. Right here is a score of, I can't write on this, but here's your score of 3 standard deviations, and we're even farther out at 4.74. Okay. All right. So let's take a look at that last one. Okay, part C says to find the 95th percentile. We've done one like this earlier. Just noticing it says find the 95th percentile. That means we are actually given the percentage. And so we need to find that earthquake line what is the Richter scale value where 95% of the earthquakes fall below that. So I'm going to, again, 95% is well above 50%. You always got 50% on this side of the mean, and 50% will fall under the other on the negative side. So out here, we definitely are going to be somewhere to the right of the mean, and all of this area under the table, under the normal distribution curve, is going to be that 95%. And so we did one just like this before. If we're going to have to use the z-table in the reverse, if you recall. So another way of writing 95% as a decimal is 0.95. And then we're going to add those two zeros because our z-table always carries out to 4 decimal places. And if you go to your table, you will discover that that is a z-score of, I'm just going to pull that one up again. Let's see, well, that's not it. Where was that z-table? I think it was here. Here we go. Let's just see where 0.9500 is. It was right here at this. Let me get another pen. You can see it here. It was right here. It's between 0.9495 and 0.9505, giving us a z-score of 1.645. It's right here between 4 and 5, so 1.645 is what we get with that one. And I'll just jot that down, 1.645. I turned on some colors here. I shouldn't have. There, lost that. No. Ah. All right. Anyway, 1.645, and therefore finally last step is we can use our formula to find what that value is. X is going to equal the z-score of 1.645 times the standard deviation of 0.596 plus our mean, which is 1.172. So go ahead and punch that into your calculator, and you will get 2.15. 2.15. So therefore, you know that that's your cutoff for the 95th percentile. The 95th percentile is going to be a Richter scale score of 2.15. 90% of earthquakes will have a Richter scale score below 2.15, and the remaining 5% will be above here with scores higher than 2.15. All right. So go ahead and give that problem a try. I will just quickly show you here. Again, you can use StatCrunch to do this. Again, keeping the same mean and standard deviation. This time, we don't know the Richter score scale. I'm just going to backspace that, but I'm actually going to put in the area under the curve, which is right here. We wanted the 95th percentile, so 0.9500. And it doesn't really matter if you do greater than. We'll do less than because we want the area to the left. And there you can see is 2.15. It actually gives us this value here of 2.15, which is exactly what we got when we computed it by hand. All right, so good luck.